Hello dear student, how are you? I hope you are all will be fine. I am also fine, thank you. Welcome to your channel as a science group. Let's start today topic. Today is lecture number 9 of nucleophilic substitution reaction. In previous lecture we started Sn1 reaction, unimolecular substitution reaction. But today in today's lecture we will be study what is the substituent effect on Sn1 reaction. And today lecture we will be study substituent effect on Sn1 reaction. Substituent effect. Substituent effect on Sn1 reaction. Today we will be studying substituent effect. So what is the substituent effect? What is the effect of different substituent on substrate? Substituent effects of substrate on Sn1 reaction. Here is many substituent like I already explained you in Sn2 reaction the substituent effect like 3 degree 3 degree carbocation, 2 degree carbocation, 1 degree carbocation, and similarly methyl, or you can say that methyl halide, first degree alkyl halide, second degree alkyl halide, third degree alkyl halide, or primary alkyl halide, secondary alkyl halide, third degree tertiary alkyl halide. Similarly, in case of Sn1 reaction, here these all types of alkyl halide have also different effects on the rate of the Sn1 reaction, in which alkyl halide, in case of when we use tertiary alkyl halide, and in case of we use secondary alkyl halide, in case of we use primary alkyl halide, or in case of we use only alkyl halide, methyl halide, which one halide will be goes, in which case the reaction rate will be goes faster, in which case the reaction rate will be faster, and in which case the reaction should be resistance, means the reaction will be stopped, reaction cannot be produced. Yeah, here is substituent effects. There is, in I already explained you that in case of Sn2 reaction, when there is Sn2 reaction, in case of Sn2 reaction, CH3, that is methyl halide, methyl halide, it goes faster reaction, because in case of Sn2 reaction, two different reactant used in rate determined step. So that's why to the reaction of, or to the collision of these two reactants, in case of Sn2 reaction, the reaction of two reactants, that is substrate and nucleophile, as the steric hindrance greater will be greater will be collision. When the collision is greater, resistance will be greater to the rate of the reaction, to the speed of the reaction. That's why tertiary alkyl halide cannot undergo Sn2 reaction, tertiary alkyl halide. While in case of Sn1 reaction, tertiary alkyl halide go faster, very faster in Sn1 reaction, while in case of Sn1 reaction the methyl halide will cannot show any reaction. So what is the reason behind this? The reason behind this is, let's suppose these all are the alkyl halides. This is methyl halide CH3X, this is primary alkyl halide CH3CH2X, this is secondary alkyl halide CH3CH3X, this is tertiary alkyl halide CH3CH3CH3X. So in case of that is simple methyl halide, that is primary halide alkyl halide, this is secondary alkyl halide, and this is tertiary alkyl halide. So in which case the rate of the reaction will be like this. Here in this case, when there is 3 carbon compound, when there is 3 alkyl group attached to the carbon, to the primary carbon, or to the alpha carbon, when there is 3 different groups attached, in this case all the alkyl group are the electron donating groups, all the alkyl group, in all these cases the X are the X are the leaving groups. So X is similar. Let's suppose X is similar, that is Cl. Let's suppose in all cases that is Cl, same. When this is same, in all cases the electron withdrawing group, that is chloride, these are same, and these are withdraw the electron from this carbon. That's why this carbon become partial positive charge, and that is electrophilic, while the chloride ion become partial negative charge. That's why the bond become polarized. In all these cases the bond become polarized. The carbon get partial positive charge while chlorine get partial negative charge. In all these cases the here is also partial positive charge and chlorine is partial negative charge. So in these cases, in all the cases, the primary, the alpha carbon get partial positive charge, while the leaving group, that is chlorine, get partial negative charge due to the high electronegativity difference, due to the bond polarization. Due to high electronegativity difference, the bond become polarized. So in each cases there is different methyl group, there is different alkyl group attached to the alpha carbon or to the electrophilic carbon. But in case of more the number of alkyl group, it will increase the electron density on the partial positive charge, mean it stabilize this partial positive charge. When it become more stabilized, it means that the chloride ion will become left the group easily, because electron density increases toward the electrophilic carbon. While in case of when there is electron density increase, it means that the bond become, the electron in this bond become easily go with the chloride ion, and the system will become ionized. So here a tertiary carbocation will be established and the chloride ion will be established as a product. But in case of secondary alkyl, here is two alkyl group attached, so it is not enough increase the electron density on electrophilic carbon as like in tertiary carbocation. That's why here is not electron density increase. That's why the bond cannot become polarized as bond polarized in the tertiary carbocation case, in tertiary alkyl halide case. So that's why in here the chloride ion cannot be easily left, and we know that the good Sn1 reaction will be those Sn1 reaction in which the leaving group will become left easily. So that's why more the number of alkyl group, it will increase the electron density on the electrophilic carbon. So that's why the chloride ion become easily left, or you can say that the leaving group become easily left the system. When it become easily left the system, after that the positive charge in all these cases, when you remove in all the cases the chloride ion, in all the cases carbocation is established, carbocation producer. But in the tertiary carbocation it will be more stable, because here is three different alkyl group that stabilize, that electron donating group are attached with the carbocation. So that's why these alkyl groups stabilize this carbocation. That's why that will become more stable. But in case of hence the reaction will be go forward. But in case of secondary alkyl halide, here when you remove the chloride ion, as the chloride ion removed from the system, or left the system, so the carbocation established, but this carbocation is not enough stable, because here is only two alkyl halide attached, two alkyl group attached that stabilize the carbocation, that electron withdrawing electron donating groups, that stabilize the carbocation. But it is not enough stabilized that in three carbocation, where where three alkyl groups attached, three electron donating group attached, that become more stabilized. And similarly it will be very less stable. But in case of this, that is methyl chloride, or when there is methyl carbocation, this carbocation will be very less stable, because here is no electron donating group that stabilizes the system. So that's why chlorine cannot be easily left from the system. But in case of when as the number of methyl alkyl group increases, the possibility of the removing of chloride ion will be increases. This is the substrate effect, that is the primary, secondary, tertiary effect. So the rate of the Sn2 reaction become it will be very less. So that is simply CH3Cl, it will be very less. The rate of this reaction will be very less. But as compared to the 1 degree, which will be less than 2 degree, which will be less than 3 degree. Mean 3 degree alkyl halide, 3 degree alkyl halide goes very faster in Sn1 reaction, because we know that the Sn1 reaction is in Sn1 reaction. First step of Sn1 reaction, alkyl, the halide ion are the halide ion will be left, the halide atom will be left the system. So that's why in 3 degree alkyl halide, in tertiary alkyl halide, it will be very easy to left the system by chloride ion. So that's why 3 degree alkyl halide will be very fast reaction of Sn1 reaction, while it will be more, 3 degree will be greater than 2 degree, 2 degree will be greater than 1 degree, 1 degree will be very greater than C3. Also you can say that CH3Cl, and that is primary alkyl halide, it cannot undergo Sn1 reaction. Yeah, these all are about the Sn1 reaction. I hope this point will be cleared. But here is one another factor also involved. The factor is that, let's suppose this is the carbocation, that is bonded with H, or you can write that is the one orbital, that is empty orbital. This is H, this is H, this is positive charge, so it is bonded with one alkyl, one methyl group, that is bonded with hydrogen, and that is bonded with hydrogen. Yeah, this is methyl, this is first degree alkyl halide. When there is halogen X attached with this system, when X is removed, it become positive charge, it become carbocation. So as the carbocation established, as the carbocation formed, produced, in this case this hydrogen this hydrogen will produce this hydrogen will these all hydrogen, this is called alpha hydrogen. We know that alpha hydrogen also take part in the hyperconjugation. Yeah, hyperconjugation is the phenomena in which partial sigma bond of hydrogen change into are in conjugation, take part in conjugation with the partial pi bond. So it can take part in partial pi bond. So this position, so this help in the phenomena of the conjugation, or you can say that it make hyperconjugation. And we know that the hyperconjugation and resonance is the factor that stabilize the system. So that's why this system will be stabilized. But in case of when there is only CH3 group, here is no alpha hydrogen attached. When there is no alpha hydrogen, it will be very less stable. But in case of secondary alkyl halide, here is 6 alpha hydrogen attached. While in case of tertiary alkyl halide, where is 9 alpha hydrogen attached. So as the number of alpha hydrogen increases, the possibility of hyperconjugation will be increased. Means number of alpha hydrogen is directly proportional to the number of hyperconjugation. So it means that more the hyperconjugation, more be stability. So that's why it will become more stabilized when the chloride ion is removed. So it also means that this system, the 3 degree alkyl halide, become easily ionized. So these all are the effect of substituent effect. These all are the about of substituent effect. I hope this point will be cleared. If you have any question, if you have any confusion, you can ask me in comment section. Similarly, there is some another cases in which resonance involved. Resonance also affect the rate of Sn1 reaction, like in case of CH3, CH2, double bond C, single bond CH2, that is CH2X. Yeah, let's suppose when there is X removed in Sn1 reaction in first step, it will produce H2C double bond CH, single bond CH2 positive plus charge plus X negative. So it produces this. Yeah, it produces this. Yeah, here is also conjugation. Here is also this double bond can be take part in conjugation or take part in resonance. So it will become like this. It will resonating stabilizer H2C CH. Here the pi bond shift toward this, so this carbon get positive charge. So this bond and the double bond become shift here. So it means that these ions or these system are resonance stabilizer. So it also means that the system in which halide ions are attached to the system, that is less stable as compared to the system in which halide ions are removed. As the halide ions are removed, the system becomes stabilized by the resonance. So that's why it will be very easy. Here in this case, the chloride ion, or you can say that the leaving group will be left easily the system. That's why it can take part in Sn1 reaction very fastly. I hope this point will be cleared. Also, vinyl group cannot, you can remember that vinyl group cannot take part in Sn1 reaction because it is necessary for Sn1 reaction, or it is not in Sn1 reaction, not in Sn2 reaction, nor in Sn1 nor in Sn2. It cannot take part in the reaction nor in Sn1 nor in Sn2 because that is vinyl and aryl group. These both groups are, that is vinyl and that is aryl, and that is aryl groups. Yeah, that is aryl and this is vinyl. This is vinyl. These both cannot take part in Sn1 or in Sn2 reaction. Neither in Sn1 nor in Sn2 it cannot take part because for Sn1 and Sn2 in both cases it is required that the nucleophile should be a take from the opposite. In Sn2 reaction it is required for the nucleophile that it can be a take on the backward region, where in case of vinyl group here is the electronic cloud present around the carbon atom, or you can say that around the electrophilic carbon. So that's why the nucleophile cannot be a take on the electrophilic carbon because of electronic cloud around this atom. It mean, it also means that it resists the reaction. In case of in case of aryl halide, in case of aryl halide, here is the electrophilic carbon also. In Sn2 reaction, the nucleophile cannot be attacked from the backside because it has the benzene group attached. So the benzene or the aryl group attached, due to the aryl group the nucleophile cannot attack to the system. But in Sn2 reaction, but in Sn1 reaction, for Sn1 reaction it is required that the system should be left, or the system should be ionizable. So in case of vinyl, when it become ionizable, it is very less stable. When the vinyl group when the vinyl group gain positive charge or become carbocation, so that is very unstable. By due to instability it cannot be take part in Sn1 reaction, it cannot be take undergo Sn1 reaction. Similarly, vinyl also very unstable. It is also very unstable when the halide ion are, yeah, when the halide ion are removed from the system or from the aryl, the system become very unstable. Due to this instability, the system cannot undergo Sn1 or in Sn2 reaction. These are the some factor that is substituent effect on Sn1 reaction. I hope this point will be cleared. If you have any confusion, if you have any question, you can also ask me in comment section. In next lecture we will be study the effect of leaving groups on Sn1 reaction, also the effect of, also the solvent effects on Sn1 reaction. In next lecture we will be study both of these effects. That these both effects are very short, very simple, very simple. I hope this point will be clear. If you have any question, confusion, if you have any confusion, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I drop in description box. You can get from the description box. and also please subscribe my channel. It make me feel happy that my student are supporting me. Okay, thank you. Very best of luck, my dear student. Very best of luck.